Okay, today we want to work on adding and subtracting fractions. We cannot add or subtract fractions unless they have the same denominator. That's the number on the bottom. To do that, we find something called the least common denominator, which stands for LCD. LCD is the smallest number that all the denominators can divide into. It's just like the least common multiplier of the denominators. Use the LCD so we can write each fractions to have the same bottom number. Then it's easy to add or subtract the tops. So for this question, we're gonna solve B, D, and F, and the rest can be done at your own convenience. Let's write the B equation in here, 1 over 2 minus 1 over 3. So the step one is that we find the LCD, which is the least common denominator, as we mentioned. To do that, we write the multipliers of 2 and we write the multiples of 3 as well. And we find the least common one and we actually write it as the least common denominator. So the multiples of 2 are 2 itself, 4, 6, 8, and so on. And the multiples of 3 would be 3, 6, 9, and so on. As you can see in these expressions and these numbers that you see here, we can see that the number 6 in here is the least common one. So we would consider this as the LCD, which would be equal to 6. Now, after finding the LCD, we convert both fractions to have a denominator of 6 right now. So let's say we want to have number 6 on both of these denominators. So what we should do right now in order to change 2 to 6 is that you should multiply 2 by 3 and you should multiply 1 by 3 as well. So you multiply denominator and denominator by the same amount, which is equal to 3, because if you multiply 2 by 3, you get to the denominator, which is equal to 6, and your numerator would be equal to 3 right now. And for the second one, when you actually want to convert 3 to number 6, you have to multiply it by 2, right? But when you actually multiply a fraction, when you multiply the denominator of a fraction, you also have to multiply the denominator as well. Otherwise, the value of that fraction would change. So in order to keep the value the same, so you have to multiply the denominator and denominator at the same time. So you would get 2 on the denominator. So that would get you to just subtract the denominators now because the denominators are same. So it would be 1 over 6. Now let's head to D. So on D, we have 5 over 6 minus 2 over 3. As I said, the step 1 is to find the LCD of 6 and 3. So what is the LCD of 6 and 3? Since 6 is already a multiple of 3, we can already say that the LCD is equal to 6. Because if you actually want to write it, we can say that the multiples of 3 are 3 itself, 6, and so on, right? And the multiples of 6 is 6 itself, and so on. So the least common denominator would be in here equal to 6, which you actually which you could actually not write these numbers in here, and you can easily say that 6 is already a multiple of 3 in this occasion. So we could actually use 6 easily. We didn't have to actually calculate these numbers. Now, after we found the least common denominator, we have to convert both of these denominators. I'm just going to write the denominators as 6 right now. And we have to convert these fractions to have the same denominator, right? The 6 in already mentioning on the first fraction. So we have 6 in here and we have 6 in here, so we don't have to change anything. And we write the denominator as 5 in here. But in here on the second fraction, as you see in here, previously we had 3 on the denominator, but we now have 6, right? Because we changed it to the least common denominator. But in order to change 3 to 6, you just have to multiply it by 2. And when you multiply denominator by 2, you have to multiply denominator by 2 as well. Otherwise, the value of the fraction would change, and we don't want that. So the denominator now would be equal to 4, and you have to subtract both numbers. So we have the same denominator in here, which is equal to 6, and now we can just subtract the denominators, would be equal to 1. Now let's head to F. So on F, we have 3 numbers. 3 fractions, I should say. 4 over 5 plus 3 over 7 minus 9 over 10, right? As I mentioned previously as well, you should first find the LCD of 5, 7, and 10 right now. So we're going to write the multiples of 5, which would be equal to 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, and so on. And we write the multiples of 7 as well. It would be equal to 7, 14, 21, 28, 35, 42, 49, 56, and 63, and 70, and so on. And we write the multiples of 10, which would be equal to 10 itself first, 20, 30, 40, 50, 60, 70, and so on. As you've seen here, I didn't continue writing the numbers as I get to 70 because this would be actually considered as the least common denominator in here because he's the only number that is actually common in both 3 sets in here and it's the least one. So we can say that the least common denominator in here would be equal to 70. Now, after you got the least common denominator, what you should do, you should convert the fractions to have the denominator of 70, right, on the 3 of them. So the first one should be actually changed to a fraction with the denominator 70, the second one as well. And sorry, this one was negative sign in here. And this one should be 70 as well. So what should we do in order to change them to a fraction that has the denominator of 70? As you see in here, if you want to change 5 to 70, you have to multiply it by 14. But when you multiply the denominator by 14, you have to multiply the denominator as well. Otherwise, the value of the fraction would be changed, and we don't want the value to be changed, right? We just want to rewrite it. So the denominator now would be equal to 56. 4 times 14 would be 56. Now for the second fraction, what should we do? We just have to multiply the denominator by 10 in order for the 7 to be changed to 70, and you do the same thing on the denominator as well. So it should be 30, and for the last one it would be times 7 and times 7, so it would be 63 over 70. And what would the value in here? It would be equal to 70, right? And you have to just subtract and add the denominators in here since they have the same denominator, and that would be equal to 23. Okay, on this question, we want to multiply fractions. In order to do so, we have to multiply the numerators, and we also have to multiply the denominators of each fraction. But actually, before proceeding with the multiplication process, we want to see if we can actually simplify them as well. Simplify them help us to work with the smaller numbers and makes the calculation easier. It also helps us to see the expression in a simpler form before doing the full multiplication. Let's say that we want to solve b as an example. The first number is 2. That should be written 2 over 1 since we are dealing with fractions in here. The second number is 3. It can be written as 3 over 1. And the last number is 1 over 4. As I said, before proceeding with the multiplication, we want to see if we can simplify them. So what I can do, I can write 4 as 2 times 2, right? So this can be written as 2 over 1 times 3 over 1 and times 1 over, instead of 4, I'm going to write 2 times 2. And as you see in here, we have 1, 2 in the bottom and 1, 2 at the top. So these would cancel out each other. And we will be left with 3 over 2. Now, let's solve another example. Let's say that we want to solve e in here. We have 15 over 16 times 4 over 5. Before actually proceeding with the multiplication part, we want to see if we can simplify them. In order to simplify them, instead of 15, I'm just going to write 5 times 3, and instead of 16, I'm going to write 4 times 4. Then I'm going to move to the next fraction. We have 4 over 5. Now, as you see in here, we have 1 5 on the top and 1 5 on the bottom. These would cancel out each other. And also for the 4, we have 1 4 on the top, 1 4 on the bottom. These would cancel out each other. And we will be left with 3 over 4. Okay, on this question, we want to divide fractions and whole numbers using a super simple method, which is called the keep, change, flip method. So basically, we keep the first number, we change the division sign to a multiplication sign, then we flip the second number, or take reciprocal of it. Let's say that we want to solve a. We have 3 divided by 1 over 2, right? So based off the method that I mentioned, we have to first keep the first number. I'm going to write 3 again. We have to change the division sign to a multiplication sign. I'm going to write multiply. And then we have to take reciprocal of the second number, which is going to be equal to 2. So it will be 3 times 2, which would be equal to 6. Now, let's say that we want to solve c. We have 6 over 7 divided by 16 over 21. Again, we're going to write the first number. Then we're going to change the division sign to a multiplication sign. Then we're going to take reciprocal from the second number. We just flip the second number. It should be equal to 21 over 16. Now, as I mentioned on the previous question, before proceeding with the multiplication, we're just going to simplify these numbers in here. So I'm going to write 6 as 3 times 2. 7 is a prime number, so it's going to be written as 7. Then we have 21. It can be written as 7 times 3. And we have 16, which can be written as 2 times 8. Now, if you simplify the numbers in here, we have 1 7 at the top, 1 7 at the bottom. So these cancel out each other. We have 1 2 on the top, at the same 2 on the bottom. So these would cancel out each other. And we would be left with 3 times 3 on the top, it will be equal to 9, and only 1/8 at the bottom. Now, at the last section, let's say that we want to solve D, which is 3 over 4 divided by 4. This can be written as 3 over 4 divided by 4. So basically, we are dividing a fraction by a whole number. This would be equal to, again, we're going to just write the first number, then we're going to change the division sign to a multiplication sign. Then we're going to take reciprocal of the second number, which is 1 over 4. And we're just going to multiply the denominators, 3, and we're going to multiply the denominators, 4 times 4, which would be equal to 16. Okay, on this question, we are dealing with improper fractions and we want to change them into mixed fractions. Improper fractions are those kind of fractions that the numbers on the denominator is greater than the numbers on the denominator. So if you look at the fractions on this question, the numbers or the values on the denominator is always greater than the values on the denominator. Looking at A, for example, we have 5 on the top and 2 on the bottom. So 5 is greater than 2. Looking at B, we have 7 on the top and 3 at the bottom. So that means we are dealing with an improper fraction since 7 is greater than 3. Now we want to change these improper fractions into mixed fractions. In order to do so, we have to know what is a mixed fraction first. Let's say that we have a number which is looking like 2, 3 over 5. As you see in here, this number consists of two parts. The first part is a whole number, and the second part is a fraction. That is what is called a mixed fraction. So it consists of two parts, a whole number part and a fractional part. Now, in order to actually convert these improper fractions into mixed fractions, you have to follow 3 steps. The first step is that you have to divide the numerator by the denominator. The second step is the quotient becomes the whole number. So after you calculate the division, the whole number would be the quotient in here. Then the remainder stays on the top. So this would be the remainder. And the divisor or the denominator stays the same. So this would be the divisor or the denominator. Now let's say that we want to solve B as an example. We have 7 over 3. So we have to calculate division in here. So we're just going to say 7 divided by 3. The quotient would be equal to 2. Then we have 2 times 3 in here, 6. Then we subtract 6 from 7 and write 1 as the remainder, right? So this would be the remainder. And this would be the quotient. And this would be the divisor. Or the denominator. So this can be written as 2, 1 over 3. Now let's say that we want to solve C, which is minus 11 over 4. The first thing that we have to do is we have to work with 11 over 4 and we just ignore the negative sign in here. Then we can actually bring it back at the end of the calculations. So let's say that we are dealing with 11 over 4 in here. So 11 over 4 can be written as 11 divided by 4. The quotient would be 2. Then we just multiply 2 by 4. It would be equal to 8. When we subtract 8 from 11, this would be equal to 3. So this would be the remainder. Now this would be the quotient. And this would be the divisor. So we can write this as 2, 3 over 4. But since we are dealing with minus 11 over 4, now we have to bring back the negative sign. So we can say that minus 11 over 4 would be equal to minus 2, 3 over 4. Now as the last example, let's say that we want to solve f, which is 16 over 3. Again, we're going to do the same thing. We're going to write 16 divided by 3. The quotient would be equal to 5. 5 times 3 would be equal to 15. We subtract 15 from 16. The remainder would be equal to 1. So this would be the remainder. This would be the quotient. And this is the divisor. So we can write this as 5, 1 over 3. Okay, now in this question, we want to change the mixed fractions to improper fractions. In order to do so, we're just going to define what they mean first, then we can easily calculate the values. So a mixed fraction, as I said on the previous example as well, has two parts. The first one is a whole number, and the second part is a fraction. The whole number is the integer in here. It's like a regular number, like 2, 3, 4, something like that. Second part is a fraction. It has some values on the top, some values on the bottom. We want to change this mixed fraction to improper fraction. Improper fraction is like a regular fraction, only the thing is that the value on the top would be bigger than the value on the bottom. So whatever value is on the top should be bigger than the value on the bottom. Otherwise, it couldn't actually be changed to a mixed fraction. So in order to actually change this and actually try to convert this into an improper fraction, you should note that the value on the denominator would actually stay the same, as we mentioned on the previous example as well. So whatever value on the denominator we have on the mixed fraction, let's say this value in here, it's going to be the same value in here as well. Only the value on the denominator would be changed, and we have to calculate it. In order to calculate the value on the denominator for the improper fraction, you just have to multiply the whole number and the denominator, and you get the result. And after you got the result from the multiplication of those numbers, you just add the value of the denominator to it. So let's solve some examples in order to comprehend this concept. Let's say that we want to solve C, we have 5 and 2 over 3. And we want to convert this to improper fraction. The improper fraction, as I said, the value on the denominator would be still the same. So we have 3 in here. We're going to write 3 again in here. Only the value on the denominator would change. In order to calculate it, you're just going to multiply the whole number by the denominator, which is 5 times 3. Then you calculate the result and add the denominator to it, which is 2. So it would be 5 times 3, which is 15, plus 2, which is 17 over 3. Now let's solve D, which is minus 3 and 2 over 5. As you remember from the previous examples, when we are actually dealing with a negative sign in here, we just omit the negative sign for the first steps. Then we actually bring it back at the last stage. So in order to change this, I'm just gonna say that I don't have the negative sign for now. I'm just gonna say I'm just gonna actually act like this is a positive number for now. So the denominator would actually stay the same again. It is 5 in here, and we have, let's say that we omitted the negative sign. We have 3 times 5 plus 2 on the denominator, right? And at the last stage, I'm just gonna add the negative sign now. So we have minus 5, and the top would be 3 times 5, and it would be 15 plus 2, which is 17. And we have minus 17 over 5 for this one. Now let's solve f. We have 8 and 2 over 9. We want to change this again to an improper fraction. An improper fraction, the value on the denominator will be the same, which is 9 in here. And for the value on the denominator would be 8 times 9 plus the value on the denominator on the top, which is 2. So it would be 74 over 9.